we have Dumois' theorem. I can never spell this dang name right. M-O-Y-V-R-E-S, I think.
How do you say it?
Dumois. It applies to raising a complex number to a power. So if z is equal to r, now z is just the variable used to represent a complex number. So z is equal to r cs theta. That's just a complex number in polar form or trig form. So if you have a complex number in trig form or polar form, you can use this formula. Then z raised to some power. It doesn't matter the power. It has to be an integer power, like z squared or z to the 10th. Actually, we should write this. N is an integer. So z to the n equals r to the n cis n times theta. All this really is an extension of this formula right here. Where'd you go? It's just an extension of the formula for multiplying complex numbers together. So, example. Here's a complex number, 1/2 plus 1/2 I. Now, in standard form like this, I don't want you to write this because you're going to have to raise it anyway. Would it really be that hard to square this in standard form? How would you do that? You would just write this twice and use the FOIL method, right? And then remember I squared is equal to -1. Would it really be that hard by hand to raise it to the 3rd power? You just add another parenthesis and multiply it out. But can you imagine doing this for the 10th power? Would that be very easy to do by hand in standard form? No, not very easy at all. But if we can change this complex number to this form right here, then we can use Dumois' theorem, and it's really easy. Right? So instead of leaving it in standard form, let's change this complex number into polar form, and then use Dumois' theorem. So 1/2 plus 1/2 I needs to be changed to polar form. It's what we practiced on the quiz. We need to find r, and we need to find theta. Exactly. R is the square root of a squared plus b squared. Theta is the inverse tangent of b over a. Ooh, and we get to work with fractions. Lucky us! So, 1/2 squared plus 1/2 squared. What is 1/2 squared? 1/4. What's 1/4 plus 1/4? 2/4, which is 1/2. So r is equal to the square root of 1/2, which is the square root of 2 over 2. Now theta is equal to the inverse tangent B, well, we already knew that. B over A. What's B over A in this case? Ooh, this is nice. 1/2 divided by 1/2 is 1. Inverse tangent of 1. What's the inverse tangent of 1? We've done this one often enough. You ought to have it memorized by now. The inverse tangent of 1 is 45 degrees. Now, always, always, always. This is the number one thing students forget. They just blindly take this without thinking about it. Okay? 45 degrees is in the first quadrant. Where's this number? First quadrant. Okay? Sometimes the angle that you use here has to be a reference angle for another angle in a different quadrant. But we can use this one here. So in polar form, 1/2 plus 1/2 I turns into what? Square root of 2 over 2 CIS 45 degrees, and that's what we're going to raise to the 10th power. Much easier to do in polar form. So if we follow de Moivre's theorem, that's going to be the modulus raised to the 10th power, and then CIS 45 times 10. So how do we raise square root of 2 over 2 to the 10th power? This is just algebra. This should not be beyond your guys' capabilities. What gets raised to the 10th power, the top or the bottom? Both get raised to the 10th power. Square root of 2 to the 10th power divided by 2 to the 10th power. It's not as bad as you think. I would, if this were me, I would change the square root of 2 into a rational exponent. The square root of 2 is the same as 2 to what power? You guys know this. The square root of 2 is the same as 2 to the 1/2. 2 to the 1/2. So if you have 2 to the 1/2 raised to the 10th power, that's 2 to the 5th. So this turns into 2 to the 5th over 2 to the 10th. CIS 450. Now 2 to the 5th divided by 2 to the 10th. You should also know how to deal with that from prior algebra classes. Maybe not this year, but last year or the year before. These are all just rules of exponents you should know. There's going to be a 2 to the 5th in there somewhere. Close. It's 1 over 2 to the 5th, which is 1 over 32. Now 450, that's more than one revolution, so take off 360 from that. Where are we? 90. Oh. Now express in standard form. So we had to go to polar form to actually evaluate the 10th power, but now we need to express our answer in standard form. This technically is the answer. That's correct. It's not incorrect, but it's in polar form. Since we started in standard form, we ought to end in standard form. So, 1/32 CIS 90. What the heck do we do with that? Anna, yep. This is 1/32 parenthesis cosine 90 plus I sine 90. Ooh, 90 works out perfect. $90 degrees, 90 degrees. Cosine is 0, the sine is 1, exactly. So this turns into 1/32, 0 plus I, which is 1/32 times I. Is that kind of cool? That standard form complex number, when you multiply it by itself 10 times, everything cancels except for 1/32I. Awesome, right? You guys try one on your own here. Nope. Nth roots are much harder than this. We do have to learn nth roots. Actually, let's go to nth roots just to make sure we have time. These nth roots take some time. If we have time, we'll circle back and do another example of this demonstration. Demonstration is pretty easy. I wouldn't worry too much about that. It's these nth roots I would concern yourself a little bit over. Nth roots of complex numbers. Nth roots of complex numbers. It's, in a way, an extension of Demoivre's theorem, in a way. We started talking about this last time. If you remember, at the end of the lesson, I was asking you about this problem here. What's the fourth root of 16? And you guys told me, okay, well, it's 2, and you're correct, but that's only one of the fourth roots. If I'm asking you for a fourth root, that means there's 4 of them. So didn't we also decide that negative 2 was one of them? So there's 2 of them. What would the other 2 roots be? Now, they actually are 2i and negative 2y. How'd you know that? Did you just wildly guess that? You're correct. Here's a problem that's going to take us back to your 1050 days a couple of months ago. How would you solve this equation? Sorry, not that one. This one? No, I changed it. How would you solve this one? Do you remember our talk about polynomials? If this is a 4th degree polynomial, then how many solutions are there? Aren't there 4 to this? So the way that we would do this, or the way that we did this back in 1050, this should be something that's in the back of your mind, like, hey, yeah, I remember this. You guys agree with this? Isn't this difference of squares now? So this turns into x squared minus 4 times x squared plus 4, right? And x squared minus 4 is the difference of squares. This is all stuff you guys could do. This is not above a pre-calculus level question right here. This is a 1050 question. Now what do we do? Well, these we can what are the answers for these ones? 2 and negative 2. And those are the ones we knew we were going to get, 2 and negative 2. But what are the answers from this guy here? Put in the quadratic formula, or you can use square roots. You just subtract 4 on both sides. You get x squared equals negative 4 square root, and you get x equals plus or minus 2i. So those are the other roots, or 4th roots, of 16. Now this is using algebra. This is not nth roots of complex numbers formula I'm going to show you. This is using algebra, which takes a little bit of time and a lot of ingenuity. Okay, but my intent was to prove to you that the 16 really does have 4 4th roots. They're plus or minus 2i and plus or minus 2. Now, if we think about 16 as a complex number, 16 plus 0i, isn't that the same as 16? It is, right? 16 plus 0i is the same as 16. If we graph that on the complex plane where we have the real part and the imaginary part, where would 16 be? It would be on the real axis, right? Now, if we're taking a 4th root, that means we have to have 4 points equally spread out around the circle, and if it starts on the x-axis, they have to be spread out equally around from here. So if we spread something out equally 4 times and it started on the x-axis, wouldn't we have a point here, and a point here? Aren't those equally spread out 4 times? The reason I'm spreading it out 4 times, we're doing a 4th root. If something's on the imaginary axis, and then on the real axis, and then on an imaginary axis, isn't it going to be two numbers that are purely real and two numbers that are strictly imaginary, like we had here? 2y, -2. Anyway, let me show you the theorem. This is not how you find fourth roots of 16 in trigonometry. This is how you would do it in algebra. So here's the formula. If you have z to the 1/nth power, now isn't a power of 1 over n just a root? Right? Like what if I change this to 1/3? Isn't that just a cube root? So that's why it's written as 1 over n. The formula is, it's r to the 1 over n. Do you see how this in a way resembles Duhamov's theorem? It does slightly resemble Duhamov's theorem. CIS, big old parenthesis, put a big giant parenthesis there. And then it's theta plus 360k divided by n, where k is equal to 0, 1, 2, 3.
Yeah, that was nice.
Absolutely.
No.
Does that mean k is equal to positive picture?
Yep.
It can't be a negative.
Mm-mm. Now, actually there was if z is equal to r CIS theta. This formula only works if z is in polar form, not standard form. So let's take 16 again. And I'm going to ask this question. What are the four fourth roots? This is how it would be asked in a test. What are the four fourth roots of 16? This is exactly how you would see it worded if this were a test question. Now we already know what they are. They're plus or minus 2, plus or minus 2i, but let's use this formula here to find them rather than having to use algebra and polynomials. Because who remembers stuff from 2 or 3 months ago, right? That's like forever ago. So z is equal to 16. That's our complex number. The problem is that's not really in polar form. 16 is in standard form. I know it's hard to think about it, but 16 is the same as 16 plus 0i. That's our complex number. It's in standard form. This formula is not going to work unless we can write it in this form here, r CIS theta. So we need to find r, we need to find theta. So how do we find r? Exactly, it's the square root of a squared, which is 16, plus b squared, which is 0. Square root of 16 squared is 16. So r is just 16. Theta is equal to the inverse tangent of b divided by a, which is 0 over 16. The inverse tangent of 0 is 0. And you can verify that on a calculator if you're wondering. So in polar form, this turns out to be z equals 16 CIS 0. Now use the formula. Z to the 1 n is equal to r to the 1 over n CIS theta plus 360k divided by n. Oh, go back up a step. Right to here. You don't use an infinite number of k values. You only use a specified number of k values, and n minus 1 k values? Here's what I mean by that. It's not as confusing as you think. In this case, if we're taking the 4 fourth roots, then what does n equal? 4. Okay, so we need to use n minus 1 k values. What is n minus 1 then? 3. So we stop at k equals 3. We do k equals 0, k equals 1, k equals 2, k equals 3. That's where we stop. Okay? Because if we do those, then that's 4 k values. K equals 0, k equals 1, k equals 2, k equals 3. So in our case, this is going to be 16 to the 1/4 CIS. Now what's theta? 0. So this is 0 plus. We've got to run through this 4 different times for each different case of k. We need to do one for k equals 0, one for k equals 1, k equals 2, and for k equals 3. So this first time around is going to be the k equals 0 case. And what is n? If we're taking the 4th root, then what is n? 4. Yep. 0 plus 0 divided by 4 is 0. So this turns out to be 16 to the 1/4 times the CIS of 0. (16 to the 1/4 would be considered the primary 4th root. What's the primary 4th root of 16? 2, positive 2. So this is 2 times CIS 0. Now we've got to put this back into standard form. This is a polar form. What's the standard form? This is 2 times the cosine 0 plus I sine 0. What's the cosine of 0? 1. What's the sine of 0? 0, you guys. Come on now. This is unit circle stuff. At 0 degrees, cosine is equal to 1, sine is equal to 0. You should be able to do that in your sleep. So what is this whole thing turn out to be? Turns out to be 2. And isn't that what we were expecting as one of our roots? I know you think, well, this takes way longer. It might have for this particular number, but the ones you're going to be doing wouldn't really be easily done using this method anyway. So that's the k equals 0 case. Now we got to do one for k equals 1. So we run back through it again. This is for k equals 0. Let's do it for k equals 1. 16 to the 1/4 CIS 0 plus 360, but instead of multiplying 360 by 0, what are we multiplying it by this time? Multiply it by 1 over 4. This equals 2 CIS. I have to take 360 divided by 4. What do we get? 90. That's the same as 2 times cosine 90 plus I sine 90. These are easy quadrantal angles. Think about 90 degrees in your head. Don't even use your unit circle because you shouldn't have to for such easy angles. Think about the top of the unit circle. What's the x value there? 0. What's the y value there? 1. So cosine 90 disappears to 0. Sine of 90 turns into 1. 1 times I is I times 2 is 2i. That's the k equals 1 case. Now for k equals 2, this turns out to be 16 to the 1/4 CIS 0 plus 360 times 2 all over 4. 360 times 2 is 720. 720 over 4 is 180. So this changes into 2 CIS 180. Again, just try to think about this without having to use the unit circle. 180 degrees, what's the coordinate point at 180 degrees? Negative 1 comma 0. So the cosine of 180 is negative 1. What's the sine of 180? 0. That disappears to 0. Cosine of 180 is negative 1. Negative 1 times 2 is negative 2. Now for the k equals 3 case, we're almost done with this one.
Would k equals 4 be the same as k equals 0?
Starts to repeat itself because of the circular nature of trig functions. So, whoa, man, 360 times 3. It's 1080. 1080 divided by 4 is 270. So this turns out to be 2 CIS 270. And at the 270 mark on the unit circle, it's 0 comma negative 1. So this is 2 cosine 270 plus I sine 270. Cosine 270 disappears to 0. The sine of 270 is negative 1. Negative 1 times I is negative I. Negative I times 2 is negative 2I. Now, you have to think about this for a second. This is not a matter of, well, this is not fun, I don't like doing this. Okay, because that's a very immature way of thinking about things. You're in an honors pre-calculus class, you have to expect to learn how to do difficult things even though it's not fun. I don't care if it's fun for you guys. That's not the issue. Learn it, practice it, okay? Master it by doing the homework. Doesn't matter if it's fun. Yeah? Not everything has to be entertaining. That's junior high thinking if that's what you're thinking right now. Right? This is going to take more than just one problem here for practice. Let's do another one. Now, here's the reason that we have to have this formula. You're going to have to find crazy things like the 5/5 roots of weird numbers like I or 2 plus 7I, just funky things. It's not always going to be something you can split into polynomials and use what we learned in 1050. Now, if we're doing 5/5 roots, how many instances of k do we have to have? We have to have k equals 0, 1, 2, 3, and 4. We have to have those instances of k. So we got to run through this 5 times. Okay? And what does n equal? 5. Because we're doing 5th roots. The problem is z is equal to I. That's not yet in polar form. That's still standard form. I is the same as 0 plus I. That's the number we have right now, 0 plus I. That's in standard form, where A is equal to 0. And what does B equal? B is equal to 1. So we first need to convert this into polar form. So we need to find R. R is equal to square root of A squared plus B squared. I know it's still early in the morning, but we got to think quicker here. 0 squared plus 1 squared is 1. Square root of 1 is 1. Now here's a little bit of a problem. Isn't theta normally equal to the inverse tangent of b over a? Do you see how that's a problem here? You can't divide by 0, so that formula actually doesn't work. But just think about this. Where the heck is I on the complex plane? If you thought about the complex plane where we have a real part and an imaginary part here, isn't this right here 1 on the imaginary axis? What's the angle from here to here then? 90 degrees. Not a super hard thing to figure out. I know I'm going kind of fast here. Time's quickly running out. Let me go over that one more time. If you were to graph I on a complex plane, you go over 0 and up 1, and it puts it right on the imaginary axis. You guys okay with that? What's the angle from the real axis to the imaginary axis? 90 degrees. Okay. So what does this look like in trig form or polar form? 1 CIS 90, or just CIS 90. You don't really have to have the 1 there. Now we got to run through each case of each case for k. So for k equals 0, we're going to have 1 to the 1/5 CIS 90 plus 360 times 0. Now what are we dividing it by this time?
5.
We're dividing it by 5. What is 1 to the 1/5, by the way? Just 1. So this is 1 CIS 90 over 5. Oof, I think that divides evenly. 18. And just for the sake of time, let's leave these in polar form so we can zip through all the other cases. If k equals 1, we're going to get 1 to the 1/5 CIS 90 plus 360. Now what do we do? 360 times 1 all over 5. That's going to be 1 CIS, oh boy, 360 plus 90, all divided by 5. That's just 90 again?
Yeah.
Cool. All right. For k equals 2, we're going to get 1 to the 1/5 CIS 90 plus 360 times 2 over 5. Ooh, we got to go. We have 1 minute exactly.
It's 162.
The whole thing turns into 162? So that's 1 CIS 162 degrees. For k equals 3, I'm recording it. 360 times 3 plus 90 divided by 5 was what? So this is CIS 234. And last, k equals 4. Hey, we made it. Sorry, you guys fall behind? We never leave a man behind. Hold on, write this last one down. Okay, now wait a minute. Here's what you would have to do at this point. Okay? Please write at least one of these down. This one, for example, you'd have to write it like this. The problem is 18 is not an unusually nice angle, right? So, oh yeah, sine. You're going to have to just use your calculator. Write this down. You guys will be fine. Quit freaking out. What's the cosine of 18? Quick. It's a decimal, so just give me 0.951. What's the sine of 18? 0.309. You'd have to go through and change each one of those back into standard form. And some of them aren't very nice angles, so just use your calculator and round it to a couple decimal spots. Okie dokie.
Okay.